Let me check. We'll say like 26.
26. Okay. All right. So it does refer back to that previous sentences about a couple investing in a rose garden. So let's do that. Okay, a couple invests $3,500 to build a rose garden. On average, it's 35 cents to grow each rose, and they can be sold for $1.75. So probably the profit, or I'm sorry, the revenue function is going to be the easier one, because every time you sell one, you get $1.75. So see how these are 1.75 times X down here on the right. Those tell you what you're going to get every time you sell one. And then we were just choosing between C and D here. So the cost, we saw some problems like this for your homework. It's the fixed plus the variable cost. So the fixed cost here is 3,500, and the variable cost is the 0.35. Okay. So that translates to a one-time charge of 3,500 plus 0.35x, or letter C. Is that reasonable?
Yes.
Okay. You're going to do more with revenue and cost in future units, so just be aware of that.
Okay. And then I'm trying, I guess we'll finish off 27 too.
27, yep. Okay. So this idea of break even, if you're in business, you understand this. Your break even is when your revenue equals cost. So you're setting those two equations you just found equal to each other. So these two equations, 1.75x equals 0.35x plus 3,500. So we're setting revenue equal to cost, and then we're going to subtract 0.35 from both sides, 0.35x. So that's 1.4x equals 3,500. Divide both sides by 1.4. And grab a calculator if you got one handy. I have not done any calculations yet, so we need to pull mine up for today. 3,500 divided by 1.4 is 2,500. And you should be on the lookout for mismatches, because if you do mismatch, you probably made a mistake. Sometimes the problems will say like between two values, between like 2,400 and 2,600, then it's a little tougher. All right, so that takes care of 27. Where should we go from here?
I'll do 40.
I'm sorry, I didn't catch that. Did you say 28?
40.
40.
Yep, 40.
40. Okay, there we go. All right. Okay, this is a piecewise problem like we were doing on one of the assignments. Okay. Neil has a sales clerk job that pays $12 per hour for regular work, less than or equal to 40 hours per week. So we did one just like this for homework. They're using H as the variable. So it's 12H if he works 0 less than H less than or equal to 40 hours. Okay. So we know we can get rid of a couple of these. We can get rid of A and E because they don't have the H in them. Okay. But then it comes down to, well, what's the other one? So we talked about calculating 12 times 40, that endpoint, which is 480. If you remember that from a couple of weeks ago.
Mm-hmm.
So then you take your pay rate, but it's not for every hour you worked. It's only the hours you worked over 40. And so you always subtract out, or you subtract the offset, or that base amount. plus the 480. Plus 480. Okay. So you notice like none of those are there, which means you just have to simplify this. You have to take 24 and multiply n times h, 24 times 40. So that'll end up being 960 plus 480. And then 24h minus 480 is your final answer for the second one. And that's for h greater than 40. Any questions on that? Any follow up?
Nah, seems good. And then I guess I'll try on number 46, like X intercepts for piecewise. Is that
I'm
just
sorry.
setting the for 46? Well,
Yeah, 46.
yeah, that's just setting the y to 0.
It sounds reasonable, like what you just said, but because it's piecewise, it's just it's tiny bit different. So you have to actually set them all equal to 0, and then see which x value is in the right region. Okay, so I'll show that here with an example here. I'm sorry. Did you ask for the x-intercept or the y-intercept? Because this one's asking for the x.
The X intercept.
Okay,
Yeah.
sorry. So for the x-intercept, you figure out which one of these three is good when x equals 0. Is it the first one? No. Oh yeah, it's the second one. So you have to know which one to put 0 in, basically. And we know to put 0 in the middle one because 0 falls between -3 and +1. Okay, so when x is 0, y is, I'm sorry, I'm so sorry, I'm doing this backwards again. This is to find the y-intercept. So to find the x-intercept, you do have to set them equal to 0. I'm sorry, to find the x-intercept, you have to set h of x equal to 0 in this case. Okay. And what I just said applies to the y-intercept, not the x-intercept. So you solve this, you're like, okay, it's -4 minus 3x, x equals 3/4, but you check, is that actually in this interval? The answer is no. Like 3/4 is not less than -3. So like this only works if the x value is in that interval. So then you try 0 equals 100 minus x. Okay. And you add x to both sides, so x equals 100. But again, that's not in this middle interval. So strike 2. But then the last one there, 0 equals 2x minus 5. Okay, you add 5 to both sides, divide by 2, you get x is 5/2. And that one does work. That one does work because it actually fits in x being greater than 1.
So check. So the answer would be C.
Yes, yes, yes. Because you're setting y to 0, finding the x value, x comma y, like that.
And so for the y-intercept, just flip the process overnight.
Well, why it's easier because you just look down the list here. And that's where I was making the mistake. I was misreading this, and you just figure out, well, which one can x be 0 in? The problem with the x-intercept is you don't know which one it actually crosses because it's not defined everywhere. There's 3 different regions in the piecewise. So the summary of a few of these is that, again, the x-intercept, you set y equal to 0, or really it's g of x or f of x or whatever it is equal to 0. And for the y-intercept, you're setting x equal to 0. This is kind of your summary of the process.
Mm, Also, can you give like a summary of like transformations and stuff, like on a
Sure.
function?
Is there a problem to look at? To
Let's
consider?
say,
Like 56 is kind of interesting, I guess.
yeah.
So we can look at that. I also might have some old test questions we could look at, but again, there's no guarantee they're the ones you'll see. Can look, but okay. So it's like, what does this stuff do? Because they're not going to give you like something you can graph. They're going to give you in this symbolic form. Do you remember what this does? Any chance you remember?
Shifts the whole graph down.
Down 4. Okay.
Yeah.
And that'll eliminate a couple. Okay. That's the y values. So the y values are affected by that.
Mhm.
The 2x here, this one's a little bit, it's not intuitive. So when it's inside parentheses, it's always kind of the opposite of what you might think it is. So this 2 is actually it's a stretch by 1/2, not the 2. So every x value is stretched out further away. So it like you, I don't want to say this, every x value is going to move left. Think of like, I'm not doing a good job of explaining this. Like this point here has got to go that way, and point here is going to go even further that way.
Yeah.
Okay, and it's a little bit odd because you might think, well, shouldn't it? But it affects the x value. So the change is that becomes -8, that becomes 2, that becomes 12, that becomes 20. Okay, and that's kind of the key one there that they're trying to get you to hone in on. And then the y values all go down by 4. So -1, -12, 0, and 1. Okay, so it's really the ones on the inside that are the most, I guess, problematic to think about.
Yeah.
So let's just to kind of do an extension of that. Let's look at 58 here. Okay, so 58. This part inside parentheses, this is always kind of opposite of what you might think it should be. So because it's +5, that means 5 left. So I'm gonna do that the other way.
So it's 5.
-5
Oh,
would be 5 right. It's just kind of opposite of what you might think it would be. All right. So that's the first part of this. You know, that the inside part is always kind of opposite of what you would think. The outside part's pretty intuitive. Like 2/7 is manipulates it, but it's because it's less than 1. So this a value, this is considered an a value. When it's between 0 and 1, it's a compression. And when it's greater than 1, it's a stretch. And then the last thing here is that this negative out in front, it's always going to flip over the x-axis.
and then there's a negative like next to the x inside the parentheses. That would be a flip over the y.
That's right. Yeah, I was going to
Okay.
get to that in one of these. So what's a good exercise here to do is look at 59, but the multiple choice, and just go through what each of them does. So that you've got that down. So A, you start inside parentheses here, and that's left 3. Because it's opposite of what you might think. Left 3, and then flip x. B is flip y because it's inside parentheses, and then up 3. C is right 3 flip X over the X-axis because that out in front. And this right here is flip, excuse me, flip X and then up 3. The order does matter, but I don't think they're going to give you anything too crazy. And then, sometimes it's better to work backwards from the answers because now when you look at the actual question, you can see that, okay, it's going from -2, 4 to 2, 7. So you can see that the y is up 3. So that tells you that it gets rid of A and D. I'm sorry, A and C. And then -2, -4. Sometimes you got, if you need to, you can do a quick drawing of it. It's like, okay, I went from -2. Okay, now I'm over here at +2. That means that it went over the y-axis. And sometimes that's the, you make a quick sketch of where the points are for that. I mean, so that's everything. There's flip, there's flips over the X and Y, and then there's up, down, left, right. And then there's stretching, I guess, stretch or compress.
And so for like the stretching and compression, so like if there is like a number in front of like F.
Yeah, so
okay.
there's two possibilities. There's A, F of X. So the one out in front is vertical. And that's the one we just looked at. If 0 less than A less than 1, it's a compress. If A is greater than 1, it's a stretch. But you got to say vertical. When it's inside, this is where it's flipped. So if B 0 less than B less than 1, it's a stretch. And then B greater than 1 is a compress. It's always opposite of what
you can say that you divide the B with the X values, right?
Yeah, that's good language.
And then for say A, you multiply the Y values with A.
That's right. One affects this affects the Y, these affect the X. And that's really what they're trying to teach you, is like what affects what.
Yeah, we're good on that. I think like my main issue now is just like word problems.
Okay. Is there one you'd like us to look at together?
Let's try like 54 maybe. Yeah.
Okay. Scrolling. Okay. All right, the function represents the cost for company to manufacture X skateboards. The company doubles the number of skateboards it produces, the cost triples. Okay, so you have to figure out, well, which one affects the X and which one affects the Y here. So when you look at this, I think the one that affects the Y is fairly intuitive. So the cost triples, that's the Y. So that's going to go outside F of X. So C equals 3 F of X. That means it triples. Is that okay?
Yeah.
All right. Now they want to double the number of skateboards. That's going to affect X. But remember, when it's inside parentheses, when it affects inside parentheses is always kind of opposite what you think. Instead of doubling,
Yeah.
it becomes the 1/2.
So you're dividing the exponent. So like
Yes.
dividing the fraction would be multiplying.
Exactly. Exactly.
Yeah, A would be the answer.
Yes.
Okay. And then for my 52. Let me see if I can.
What I'm sorry, what was the next one?
52. I'm just looking at.
52. Which one of the following transformers? Compression, horizontal stretch. Okay, so vertical compress means the number outside has to be between 0 and 1. So that could sort of A, C, D. The stretch is always, it's kind of the opposite. So it, like I don't want to say this, like the wording, I don't want to mess up the wording here because it's so important, but like normally you would think of a stretch as being a whole number because when it's vertical, a vertical stretch would be like 2. But then because it's horizontal, it's always the opposite of, or flip of what you think it is.
Yeah. Yeah. So do 50.
All right, 50. Here we go. Snip that in. Function d equals f of x represents the average distance traveled. Suppose the point 10 to 50 is on the graph. In 5 years, advances in technology allow the car to travel twice as far with the same amount of gas. So what is the twice as far? Is that affecting the x or the y? So that's really what you've got to decide here. And remember,
Y.
it's affecting y. So we know that this number doubles. So that gets rid of those down to B and D. Same amount of gas, so that's no change in the input. So we would choose letter D.
Try like 36. That's kind of a scroll.
Right.
36. Okay.
Let me snip this in. Right, a concert venue holds a maximum of 1,000 people. With ticket prices at $50, the average attendance is 600 people. For every $5, the ticket price is lowered, approximately 25 more people attend. Which of the following represents the number of people attending as a function of price? A couple options here. One is you could actually write the function, or you can figure out which function satisfies the data points. Which do you think you're more likely to do? To write the function or to test the answers?
Write the function.
Okay, so we gotta be careful what's x and what's y. So it's x comma y is p comma n. So for $50, there's 600 people that attend. But if it's lowered to 45, 625 people attend. So you have to find the slope between those 2 points. This really is the key here is to do this part. So y2 minus y1, that's 625 minus 600 over 45 minus 50. So 25 over minus 5 gets you down to minus 5 as your slope. So that eliminates a couple of answers here. Once you get that far, y equals minus 5x plus b. And this is when I would probably switch to the other variables. N equals minus 5p plus b. And then you choose one of the data points. I'll just choose the first one. 600 equals minus 5 times 50. 600 equals minus 250 plus b. Add 250 and b equals 850.
Okay, so you just use a slope.
Yep. Write the equation. If you had enough time, you could test that both points worked in there. They should.
See if I can find one. I guess I'll try 19.
Okay.
And then, well, since you use Desmos, but like, I use like a TI-84.
Sure. I'll show you.
Is there like, yeah, I was just wondering if there's like a trick to like finding the window, because like that's the main part of this problem. It's just finding the window of the graph.
Yeah. Let me get up the virtual TI-83 and show you what to do here. Here it is. Tools TI-83. Okay, so let me. I'm going to share that other screen, the virtual TI-83. All right, so if you're seeing my screen here, hopefully that loaded up. Did not load up. There it is. Okay, so you go right to y equals, and just you got to enter this in really carefully. 1 over, at least mine. I don't have the 84 x squared plus 258x minus 38250. So there's not really a trick. There is just observing like that hits when x is 0, y is minus 38,250. So that gives you kind of a magnitude of the numbers. If you've already graphed this, you know that you don't see anything when you graph it, which is pretty frustrating. So here's a few things you can do. You can do a zoom fit, which is an attempt for the computer to see if it's right or not. It doesn't work great, but it will do something. You will see something. Okay, but you can see there that that's basically garbage. Doesn't help you. So go to the answers. Do you see how the answers, they give you some of the intercepts? Like 150 and so I'm tempted to change our window to go from 0 to 13,000, because one of the intercepts is there at 13, says it's at 12,750. You probably want to change your scale to either 0 or like 1,000. Y min, what's the biggest, the Y that it could be? Well, this is just a guess. It's obviously going to be pretty large. So you just make a guess, like 100,000, and you go up by 10s or by 2s. This is just a guess. So let me change my scale to 10,000. Okay, so I got lucky. I kind of saw something, but it's way too big. So we need to scale the X back quite a bit. Maybe I added an extra 0 on that, and then the y is about double too much. So the x max, let's make it maybe I didn't enter this in right. Is that possible? Minus, oh, I didn't see that. So I didn't put a 0 in. I
Oh,
was
yeah.
wondering why that. It's so because the graph was fine. So on the y though, let me just go graph it again. So there it is. So now this is way off. Okay, it's not even close to tall enough. But I got at least the x. So you go back to your window, and again you can use things like doubling or powers of 10. Because I'm so far off, I'm going to add another 0. Let's see if I can get a little better. And there it is.
Okay.
All right.
It's just trial and error.
Yes, it's just trial and error, but reasonableness. Sometimes that zoom fit does okay. Sometimes it's garbage, but all right. Well, that's going to do it for us for